always wonder why we come to these conferences. And for myself, it's because if I'm lucky, listening to everybody else, I get a genius idea, which then becomes part of our product and helps us to keep selling it. It doesn't happen every year, but there have been a few sort of star ideas which have come to me over one of these weekends. Now, about 6 years ago, it was one of those conferences which produced rather mixed results, in that I had a couple of utterly disastrous ideas, which turned out to be complete dead ends and which have taken me several years to tidy up afterwards. And I had this one idea when I first introduced the idea of the fourth query language, which has turned out to be absolutely brilliant, even though I didn't realise it at the time. So when I first talked to most of the same people here about the fourth query language, I have to confess that it was about 98% vaporware. And so when I got about a dozen emails after the paper had sort of found its way onto the internet, asking for the source code, I had to reply with one of these automated messages saying that I was actually on holiday for the next 2 years and would respond as soon as I got back. So, it did take me about 2 or 3 years to finally implement FQL, and I've slowly moved all the new parts of my application over to that, and it's been extremely successful. Just to tell you a little bit about what FQL consists of, it's a method of merging the best features of two completely different programming languages. So SQL, structured query language, is the standard method for extracting information from databases. It's structured query language, which means that it's not possible to structure it. It does quite a lot of other things besides queries, and to a fourth programmer it's not a language at all, because it's a declarative language. The language SQL describes the result that you would like to see without hinting in any way as to how that might be achieved. That's all done by the SQL query compiler, which then looks at all this stuff that you've written. I was about to say garbage, but it wasn't. It's not always quite as bad as that. Works out a program as to how to do it, and then gives you some results. But it is not the kind of language where you can in any way influence the procedure which the SQL uses to do it. So if you have a calculation which uses a combination of extracting information from a database and then putting it in a particular combination and order where a procedure is required, then SQL is extremely bad at this kind of query. And that sort of information is actually quite common. And I've got this little example here. I'm not sure if you can read it, but there is a copy in the handout there. Now this, I should say that there are some unfortunate people in this world, in fact about 99% of them, who actually have to do some work, unlike us, you know. And in this particular instance, these poor people down the left-hand side are all working at packing laundry. So next time you go back to your hotel room and think about the pillowcase and the sheets and the towels and all the rest of it, you have to realise that back at a commercial laundry, which is a vast, great factory with steam coming out of it, there are some poor people who are working at the packing department, making sure that House Risson actually has all the right laundry cages with the right number of towels and sheets and all the rest of it in there. And so at this particular laundry, we are looking at an analysis of how many man-hours were used in 1 week in the packing department on each of the days. And you can see that for this particular laundry, it's a 7-day operation. So unlike us programmers, you know, of course we don't work over Saturdays and Sundays, well, apart from this weekend, of course. Now, the raw data for this consists of a database table which has the login and logout times of all of these operators for all the different locations. So this is a very, very simple database table. Operator reference number, action, which is login or logout, and the work zone that they were logging in or logging out. And to produce this, you would have thought this was an extremely trivial thing to produce. It's actually remarkably complicated. One of the complexities is, of course, that the laundry manager wants to know the analysis by day, and some people work night shift, which means that they log on before midnight on Sunday or something like that, and they finish work after midnight on Monday. So part of their work time is allocated to one day and part to another. And of course, you're doing it over the period of a week, so somebody might have logged on the Saturday and still working at the end of the period where you're doing the calculation. So, trivially, you extract the data from this table and try to pair up the login and log-off times, and then for unpaired login and log-off times, you insert the appropriate end time or start time, which is basically midnight. Either midnight the day before or midnight the day after. And that part of the job, putting the pairing together and inserting the end times and start times for the orphans, is extremely easy to do if you have a procedural language, but accursively difficult to do if you are working only in a declarative language. So this little application here is absolutely ideal for the fourth query language, which enables you to put together the best of both worlds. And here is a little example, which is the very first step of a multi-step process used to get that actual report. So we have some examples of fourth query language here. The key symbol is this little vertical thing. It was the only single character that I could find on my English language keyboard which is not actually used for anything else. And it's actually the Alt-GR top left-hand side character. This worked absolutely fine until I discovered it wasn't present on a Chinese Hong Kong keyboard, which left me in a bit of difficulty, but that's one thing to be overcome, and I'm sure somebody will make a fantastic suggestion here in this conference as to what we do instead. So, anytime you see this little vertical thingy, it means I'm going to switch from fourth to SQL. So we start off, of course, in fourth, and we do SQL and a little vertical thing. I haven't actually got a name for this little vertical thing either. What's this little vertical thing going to be called?
Bar.
Switch.
Switch? No.
Yeah,
Well,
okay,
no,
SQL
that
switch.
one's not bar, that one's broken. There are two different bars.
Yes.
There's the solid one and that one, which is the broken bar.
Broken bar. Broken. Ah. No, I don't really want to use the word broken in the program, really. But that happens automatically anyway,
it's
not
a
like a
split
garbage
bar.
collector. Switch. So SQL switch.
Split bar.
Yeah. So now we're in SQL. Now, as soon as we switch, everything until we see the next switch, which is actually down here, all it does at the compile time is actually pop it just saves all this string, and then at execution time it copies all that into a string, basically. Because when you actually execute a query in SQL, all you are doing is sending it an extremely long and complicated zero-terminated string. So what you need to do is find some way of accumulating that string and concatenating it. So we get down as far as here, and then we switch back to fourth again. And we call another fourth word which inserts the where clauses. These are the selection clauses. So that's the information that we want from the database, provided each of these factors here in the where clause are true. Now, typically, this information down here, for example, the timings, are actually set by the operator when he selects the report. So these are dynamic, if you like. So you can't just write down the whole query in one go, you have to create the query dynamically. And that's another real advantage where fourth comes in. So we are actually putting it in there, a selection clause for all the time period over which this weekly report is generated. And then we switch again and switch again, and finally at the end we do the order clause for the SQL, and then we switch back and we say execute that query and give me a pointer to the result. And in this case we need to do some more processing on the result because we need to do all this pairing and dealing with the orphans. So now what we do is we insert the results of the first query into a memory array which we've created, and then we can do some fourthy procedural things to it to put it all in order. I won't start again, sorry.
And now I'm late, sorry. I'm not the only one.
So I've not gone into detail as to how we do the pairing and all the rest of it in the orphans because that's relatively simple stuff. But assuming then that we've got another temporary database table which we've created as a result of putting all the information together, this is our final query. It's actually embedded within another piece of code there, so it's not got the SQL switch to start with. It just starts with a switch because you're already prepared the SQL. But this is the final result which produces the report I showed you a little bit earlier. So these are all the column titles there. But now not only are we using the fourth to insert certain parts, we are actually using the fourth to insert subqueries, which we then join into the main query. Now, if we type this, if we allowed it to print the whole SQL query for this, it would go on for pages, and it would be completely unreadable and unmaintainable. This is one of the problems we had. Some of our queries were getting 10 pages long, very, very difficult to see the structure of the query, and if you come back to a query that you'd written 6 months ago and tried to make a change to it or find out where a bug was, you couldn't read your own code. Hello?
So why didn't you use stored procedures then?
Well, there are alternatives to doing that. But if you use stored procedures, you would want to dynamically create those within the fourth as well.
You do?
So, oh yes, because in a way, you don't know really in advance what some of the parameters are going to be. They're going to vary between different, some of these reports are extremely flexible. You can insert a very wide variety of parameters into them. I'll show you one of the report forms in a little bit. So I think you would need to somewhere dynamically creating the stored procedures, which adds a further level of complexity to the job. It would be an alternative way of doing it, but I think you can see from my previous example that even in a relatively simple query, I like my code to look like a poem. It sort of like scans, doesn't it? So not only do I do all my indents, but I line things up so that my switches are all lined up here,
Yes,
down there like that. It really does help because it enables you to see any mistakes that you've made. If you don't line the stuff up, then it's very easy to accidentally leave some little dupe out or something like that. If you line everything up, it comes out quite nicely. But yeah, so this inserts, this chmin thing there, inserts a subquery. And you can see that the subquery construction is reused all the time with a parameter for the days of the week and one final parameter for the total at the end. And here it is in there. There's the subquery. So we switch back into SQL. The subquery is between the brackets there. But in the middle of the subquery, we switch back to fourth and insert the parameter for the day. And that calls another little fourth word up there, because if it's the total, you want to do a kind of if 1 equals 1 result in order to combine all the days together. So up here it just puts if the day is equal to 1, 2, or if it's -1, then it just puts in a query 1 equals 1 to give the whole result. So, did I have anything else to show you? I can't remember now. No. Okay, right. In that case, we will look at some real results. This just to prove that this does actually work. And this has transformed the situation. Because now, instead of having large queries, we have queries which are conveniently broken down into much smaller sections. We have eliminated the use of complex features of the SQL language. And SQL, I have to tell you, it has some similarities with Forth, in that there is an ANSI standard which nobody sticks to. So, actually, the ANSI standard, I mean, in theory you could stick to the ANSI standard, but actually it doesn't include some terribly useful things, I would say some necessary things, really. The last version that I saw, for example, did not include roll-up, which is, I would consider, is absolutely essential, because otherwise you have enormous great unions repeating the same query, but to create a total result. So if you try to stick to only the core features of SQL, you are much less likely to get into trouble when a new version comes along. And FQL enables you to put together lots of small queries in order to create one big one. And that has a further advantage in that if you do a query which takes quite a long time to calculate, you can use the breaks in the query to generate a progress bar, which you can't do. If you send SQL a huge great query, you have no idea in advance how long it's going to take. So you can't really put up a progress bar. So if we do a horribly complex one, like calculating how efficient people are. I do these things for other people and they're horrible. You know, I wouldn't like anybody to calculate how efficient I am. But here we are. Let's just calculate how efficient these poor people are. As you can see, this is a mean laptop. This is the best I could possibly buy, but it's still taking actually quite a while. This is the efficiency for a bunch of operators in this particular factory over a period of a week. It is a long and complicated calculation. And the remarkable thing is that these people do not work hard. Look at that. Would you say, any of you, that you were 110% efficient? There's one or two there. So that's one example of where the query, which formerly consisted of one single 10-page SQL query, is now broken down into lots and lots of small ones, all nicely merged together, and with other bits added to it, to take advantage. And incidentally, that query now works something like 4 times as fast as a result of being lots and lots of small queries compared with one long query.
But if you're doing small queries, are you also shuffling the data around between the client and the database?
Between?
Your application to the database?
Yeah, are we putting data both ways?
Yes.
But sometimes we are, yes. Sometimes we are creating intermediate tables, because the second part of the query, you probably saw earlier on, that a second part of the query, in order to use the strength of SQL in bringing things together, sorting things, selecting things, always use SQL for that. Because their compiler is far better than my brain at doing that kind of work. But for other things, you know, you soon get to realise that if you merge them in the right way to use the strength of both languages, then the performance of the application improves enormously. Here's another little one. So we'll do a little graph now. And again, formally, we try to get all the results of this particular little graph from one SQL query. And now we're doing it, and as you can see, it spreads, instead of waiting for all the results to be ready, it spreads all the way across as you're doing it. So the operators don't get bored while watching, even on a slow PC. And it's improved the reliability as well. You would have thought, I had some problems 2 or 3 years ago with that operator efficiency SQL query. And every now and again I would get database table corruption. And if you Google MySQL database table corruption, when you finally get down to it, the only actual thing can possibly be a bug in MySQL. MySQL undoubtedly has bugs. Those bugs are only apparent if you try to misuse the language, in my opinion, by giving it something which is just too big for it to bite. That problem has completely gone away. Now I've split the very large SQL queries into smaller chunks. Even though you're getting the result, and you're getting the result quicker, the whole program is more stable than it used to be. That's about it, really. I haven't told you anything about the implementation of this, because it's all written in an obscure dialect of Forth, which a certain person here keeps telling me I should have thrown out years ago, but the reason I keep using it is because he made a fundamental commercial error and created a compiler which was so stable and so reliable that it started work in Windows 3.1 and still works perfectly in Windows 8. There it is. Thank you very much. Any questions? No, nobody wants to use SQL.
Well, as long as we can avoid it.
The question is, so you construct a string from,
Yes.
from the query.
Yes.
You fill in the stuff that's in between, so that's in between the bars.
You are dynamically creating this query, yes. And then
Well,
you might get the result.
let's show a query here.
Let's look back to the original query.
Yeah.
Yeah, we can do. Where was I? Oh, there, I think. There's a simple one. Yeah.
So this log on off produces a string or what?
Yes. That says where operator action equals log on to work zone or log off from work zone.
Yeah, but my question is, so what is the stack effect of this word?
What, this bit here?
Well, any of these in between, yeah.
Right, the actual string produced there would actually say where brackets op action equals whatever code it is, whatever enumeration it is for log on to work zone, where op action equals 1 or op action equals 2, for example. And this one here would do, it would actually produce and log systime between first date of selected report band and last date 2359
So
of selected report band.
that's the part of the query.
Yes.
My question is, what is the stack effect of this code?
The stack effect? Oh, none.
No.
No,
So-
the whole overall thing here.
No, I mean of the part between the bars.
Oh, there's no stack effect on there.
So how do the strings get across or whatever you... how do you-
Right. I didn't actually go into.
With the broken bars, I saw it. You just in channel log off, you use the broken bars again to insert.
Yes, you continue
Versus
on your
the-
inserting. Now, I suppose it does, in the paper it tells you a little bit about it. Now, because some of these queries can take a long time to execute, in practice they're almost always done in threads. And there are different types of queries. Some of them are done as a result of operator request. But some of them are continuously recalculated in the background. So you may have several threads doing queries all at the same time. Now, if two of those queries happen to clash and both request information from the same table while at the same time some other thread is trying to write to that table, then thread locking may cause a delay. So you don't even know, you can't even really estimate in advance how long it's going to take for the query to execute, but you can tell that sometimes this is a noticeable amount of time. So all these threads are done in the background, which means that FQL needs to be thread safe. So the buffer and buffer pointer, which is used to accumulate this enormous great zero terminated string, is actually part of the thread local variable structure. So when you do SQL switch there, all that does is initialize the pointer to the buffer, which is available for the particular thread in which this word is called.
So you basically the log on off puts more string into the same buffer.
Yes, it's
and the
concatenating
buffer
strings.
is
Yeah.
accessed through a user variable.
Yeah, it's adding information to this string. It's just adding and adding and adding and adding until finally you get to this bit here, and the input parameter to this word here is the final pointer to. No, I changed that. It doesn't have any pointers. It uses a fixed pointer. So SQL greater than sign there says, okay, I've finished now. Do the query and pass me a pointer to the result set. And oh, there's one thing I haven't shown you. It even works interactively. I meant to show you that, didn't I? Yes. Where's my allegedly? I still got that there. No. Let's look at a little bit of the end of the source code, where I have sort of. I'm not. I wouldn't like to memorize all this. Let's reselect that. Here's a tiny little thing. Not. Because I've got a dialog box open. So. There we are. I didn't actually type it in there because there's a little bit to type there, but there's a very trivial query which is effectively working interactively. And at the end there we get the pointer to the result. SQL result there then takes the result set and formats it nicely on your debug window there in exactly the same format that you see in all the SQL textbooks.
Yep.
So, and you can type away there. My only restriction on the implementation so far is that between the switches, all that must be on one line. But that's probably an implementation difficulty which you could get over if you wanted to. But in practice, if you were practicing trying to get the query right, you do it in a query browser anyway. You probably wouldn't do it in the forth. But it's nice to just do a few simple things directly in forth. So you're actually executing SQL directly from the forth debug.
I'm still wondering why it takes so long to fetch a report for the workers for 1 week. How many lines of code are there in this table?
Oh, these tables are huge.
What is huge? Millions of lines?
Yes.
Okay. And
Yeah.
they are indexed properly, and you have the index.
Yes,
in memory,
believe me, I have
and
spent
this-
a long time on optimizing the indices.
Okay.
Yes, absolutely, yeah. Yeah. And
So why aren't you then just taking the old parts and moving them to a different table? To partition the table?
I experimented with doing a prior extraction of chunks of the table and putting it in a temporary table.
No, not like that. I mean, you can have one table and just partition it. And you would have the recent events in a fast database, which maybe is also cached in the memory. But the vast amount of it, which is older, will just be...
Yeah, I mean, these reports can be produced over any arbitrary period.
Then we just take longer for all the reports. I mean, are you going to... is the operator going to ask for a report for,
But
let's say, 2 years ago often, or is it more likely that
on the graphical report, which I showed you, the histogram report, a yearly report is common because the laundry managers are looking for trends. they're looking basically for a steadily increasing graph of productivity. So yes, these long queries and a completely arbitrary set of parameters for the query are common. So although you could, if you want to do last week, you know, you could partition it off by the month or something like that. You probably could, yeah. But it's another level of complexity, and it wouldn't work for all cases, really. And the result now is an acceptable speed. So yeah, it seems to work reasonably okay. I'm really pleased. I think this is the best new idea that I've had in Forth for a number of years. 6 years ago, there were two other ideas which we had during the conference, and my colleague Kasper Swiatkowski came up with this idea where you don't program in SQL at all. You imagine that the SQL table is actually a flat file, and you use open file and read file and all sorts of stuff like that. And there is the structure of the database table is replicated by a fourth structure. And that is an interesting idea, except of course you don't use any of the strengths of SQL. You are purely using it to select data, to select and store data. And that resulted in slow queries. It resulted in much longer code, because all this open file business, and then you have to do the fiddling around yourself and do all the totalizing yourself. When I converted a query recently, I made a note as to the code length and the execution time, and I've actually got it in the paper here. Compared with previous methods, FQL has made a saving of about 50% in code length, even though I've taken quite a lot of trouble to optimize the poetry of the Forth to make it readable and maintainable. And there are some queries where the improvement in performance has been spectacular. You know, a factor of 10 is not uncommon.
How the heck do you have an improvement in speed? As far as I have understood your idea, you are using Forth to have a more flexible way of producing query strings.
Yes.
Well, then basically SQL
Here's
does the
my-
same thing as before.
Here's my observation. If you throw a query which is that long at SQL, and it takes that amount of time, if you throw a query which is 10 times as long at SQL, it is non-linear.
Are you sure? I mean, if you reorganize all the queries,